Right, let me take a new notebook. So in this notebook, I'm going to have some graphics, especially when we want to talk about the graphics. I will say like group 2. So that is what I'm going to use. Now for that, we are going to use another Python library. So if you are interested in learning more, right? Okay, yeah, maybe I couldn't. Let me share. Sorry. Can you see the screen now? Okay, right, yeah. So I actually created a new notebook, but before that I would like to visit the official page for Matplotlib, especially for visualization Python. We are extensively using this. And then if you look at like examples, you can look at there are a lot of example graph you can access there, and then if you need a particular thing, the code is already given to you, right? And most of the things now you should be able to understand. Now for example, in the graphics you will see most of the time for data generation they are using numerical Python, which we have covered earlier, right? So let's start the basics. I will start from the very beginning. Now the two, we normally when it comes to plotting and data analytics as well, we are using two modules very frequently, right? So the two modules that we will use, the Matplotlib for plotting. So let's look at how to use that. Normally we use import matplotlib.pyplot, right? And let's shorten this one. We will say PLT. I will explain why we will put it like this. Then second, we will use NumPy. We can use import NumPy as NP. Right, now this is for plotting, the first one. Second one for data generation. Right, so that's the first part. So let me run this. Now usually when you want to visualize something, you need like values, x and y values usually, right? You have x-axis and y-axis. You have to have a set of values. So what I'm going to show you is a generation of a sine plot. That means y equals sine of x. So that is mathematical graph. Let's look at how we can generate that. Now, since we are going to do plotting, we need to define what x is, what y is, then we can use plotting. So let me first define what x means. Usually we know the range of values. So this is a vector we are going to define. So for that I am going to use np arange. Arange, remember we had three parts: start, stop and step. So I will start with minus pi. This is sine curve I am going to draw. So I will start with minus pi to plus pi with the step of 0.01. So if I could draw, this is like one side we have minus 5, the other side we have plus 5 with the step of 0.01. So that is x. Similarly, y we can define as a sine of x. So np sine of x. So I think this is the first thing. See, if these mathematical expressions are confusing for you, you can take something like, okay, y equals 2x plus 3. A simple curve you can use. Right. Now let's plot this. Plotting is plt.plot function. This is only what you need to remember. You can simply say x and y, x comma y. And finally, right, we can have a show. Right, this is to show the figure. So if you run it, if you have done it successfully, you should be getting a sine curve like this. If you have finished up to this point, please let me know by raising your hands.
Can you go a little up with the important?
Okay. I'll copy paste this in the chat. Right, unfortunately I cannot access the chat session, maybe because I connected today using my personal account. That might be the reason. So if you have any question, please ask me. Otherwise I have to go and come back with the new. I'm unable to access the channel right now. How many of you were able to finish up to this point, this sine curve? Right, thanks a lot. You can lower the hands now. Let me move on to customize this graph. When I say customize this, what I want you to do is change of colors, change of markers, change of line types. That's what I'm going to explain right now. Right? So that's exactly what I'm going to explain to you. How we could change. Right? How can we change the color of the line, the markers, right? Things like that. Right. First of all, let me copy paste this one so that I don't have to spend that. I keep the values as it is. I'll paste in a new shell. Right now I know when I put this, it'll be the same. Right. Now, if you want to modify the details, you can go further. You can have a text string, right? String to generate. So let me put a comma. When I put a comma, you will see this plot command. And if you go down in the help, you can find out how to change, right, different details. Now, for example, The formatting string that I'm going to define contains marker, line and a color. So you can have any combination of this. Now for example, let me go to the colors. There are many representation of colors using hex string if you want, but the basic colors can be changed by using these characters. Now for example, if you put B, you will get blue color. If you put G, you will get green color. If you put R, you will get red color. Now simply let me put this R, and if I rerun, you can see that the color of the line is turned into red. Right? If you put G, you will get green color. Yes. And that's about the colors. Like colors, you can have markers as well. No, line types, let's say. So if you put comma, so you can get the details of line types. So here are the line types. If you have a dash, it's a solid line, and this is the default. If you have two dashes, dash line, dash and dot line, dotted line, right? Let me show you. Now if you put dash, no change, but I remove the color, so you will get blue color line. If you put two dashes, it will be a dash line like this. Then if you put dash and dot, the line type has changed to dash and dot. And finally, if you put colon, it will be a dotted line. So now we discussed two things. We can change marker, we can change color. Sorry, line type. We discussed line type. The third one is markers. Right? Markers means you know that you can have points. Right? We can have point markers, pixel marker, circle marker, triangle marker, and so on. Let me put that one. Now for example, if you put a dot, so it will look like this. You don't see this because it will look as thick because the step is very small. So let me change the step. Let me have it 0.3. Now let me run again. Now you can see the marker. Right. Similarly, you can have circles. Oh. Yes, you can have circles. Or you can have triangles. Sorry. Right, we can have triangles like this. Okay. So that is individually we are changing. So we can combine. Now for example, let me put like this. I want to have a red color with circle with dash lines. We can put it like this. Red color, dash line with circles. Right? Similarly, we can change like green color, triangles, dash lines. You can experiment. So this time it will turn into green, right? So I can have a small note on this, right? We can have formatting string. You can have formatting string to change color, marker, and line type. Right. If you finish up to this point, please raise your hands. Okay, thanks everyone. You can lower the hands now. Thanks everyone. You can lower the hands now. The next thing I'm going to do, I'm going to add elements. You know that when we creating a graph, we have to properly mark the axis values. We can have legend, you can have title, you know, this information, right? So let me discuss those with you. Right. Okay, let's start. I'm going to get a new one. But before that, tell me whether everyone has finished or do you need more time? Anyone needs more time? Okay. Yeah. So I hope everybody finish up to that part. So let me take a new code. I'm going to use the same function, right? But with slight different details. So let me take the same thing. Let me copy paste so that easier for me. Right? So we have a sine curve, and let's say I'm going to change this now. This is green line. No? Let me change color to red. Okay, and then marker to star, and the line type as a dash and dot. Same thing, but different values. Right. Now I can modify by adding more commands. Like for example, if you want to have a title, we can have plt title, and within brackets we can have the whatever you want to have as the title. So I'm going to say y is sine of x. So if I run it, now you can see we have put a title. Then Similarly, you can have labels, X label and Y label. PLT X label, we can say it's angle in radians. So that's x-axis. Similarly, we can run. If I run it now, you can notice that angle radians in the x-axis label. Then similarly, we can have y label. For example, that is sine of x. So this side we will have sine, this is angle. If you need grid, we can have grid. So the right now we don't have anything here. You can have a grid. Easily you can read the point and point values. Then we can have legend. Right now, since you have only one curve, that is not very useful, but you know, legend usually put at as an list. So within the list we will have sine of x. We can put it like this, right? So these are the main elements of a plot where we need to, you know, mark, so that we will get a complete, you know, plot of y equals sine of x. Right. One more thing, now if you feel that this title is not large enough, you can change it here by adding more details. I will show you where you can find this. Again, you can find the what do you call the help. Once you look at the help, you can get the details. Let me show you. When you say a comma, usually you can access the help. You can say second part, font dictionary. Font dictionary is none. So that means you can have a dictionary of values to change the font. Right. Let me go down. What are the things you can have? You can have font size with some values, font weight, font color, vertical alignment, horizontal alignment. Likewise, you can make it as a dictionary, right? Let me have only the size of it. For example, I'm going to change the font size. So to change the font size, I can put it as a dictionary, and then I will have key and value pair. So the key is font size. I think I can have 20. Right. So if you do that, and if you run it, yes, now you will get a large font. Right. I think this is enough for you to have a basic plot. So you can change x and y combination, and you can get, you know, using this piece of code, you should be able to get a basic plot now. Right. Any questions on this, please? Any places you are not very clear about? If you finish, can you please raise your hands? Nahil, have you finished?
Yes.
Okay, thanks. Okay, let's move on to the next one. Next part, I would like to discuss how to draw multiple plots. Right. So let's start with the new one. We want to discuss multiple plots. Right. Now let me define x. We know that we have to define x anyway. So we have to use np. I'm going to use a range. Let's say this time I'm going from minus 2 pi. So when you say minus 2 pi, we will write it as minus 2 into pi. 2 plus 2 pi with the step of 0, 1. Right. Now let's say I'm going to have 3 curves and I'm going to say them as y1, y2 and y3. So let me say y1 is the same thing, sine of x. Let's say y2 sine of x minus dot pi by 2. Then y3, this is some curves, right? P dot sine of, this should be minus x minus np dot pi. Right. So let's have, this is the first method. I'm going to say method 1. So this is how we are going to say we will have plot command. Remember we have x and y last time. So this time we are going to have x comma y1. Then x comma y2 and x comma y3. So this is how you can do, and then we can say dot show. That's all. So only thing you need to remember is when we have like more than one curve, you can use a plot command. You can have xy pair. So if you run it, you see we can see 3 curves which represents these 3 curves. Now that we cannot find what those curve, I think legend is very important here. So I can put the legend. You can say PLT legend, and within bracket we can have a list of values. The first one is sine of x, then second value is sine of x minus pi by 2. Sorry, you don't need these brackets, only one bracket is enough. Sorry. And then sine x minus pi. No, these are the three. We type what we need to have. So we would display it as a sine of x minus pi by 2, and sine x minus pi. So if you run it now, you see, yes, the legend is indicate this blue color represents the sine of x, green color represents sine pi by 2, and then third one, so bracket is missed here. The last one sine x minus pi. So that's how we will draw three curves. This is method 1. Right. If you finish up to this point, please raise your hands. Peripun, are you finished? Peripun, your voice, okay, yeah, thanks. Okay, let's move on to the second method. So the second method is nothing new, but what you can do is you can simply have separate plot commands for each plot. So we can say plot x comma y1, right? And then we can say plt dot show. Right now we have only one. Similarly, we can have plt dot plot x comma y2. Now we have two plots, right? And finally we can have y3. So you can have the legend like in earlier if you want to mark it down. But simply the difference from the previous one, here previous one we had only one plot command. Here we will have a separate plot command for each of this xy combination. Right. Okay, so let's move to the next one then. So next one I would like to discuss subplotting, which is we can have several graphs in one figure, right? So this is called subplotting, and whenever you want to represent your data in the same, right, we can separate out, right? Let me take the same example here. So what I'm going to do this time, I'm going to copy paste the same thing to a new coding window. Sorry. Right. So we will have this X and 3 graphs. So this time I'm going to have separate them in a one figure. Let me show you how. So the command that we need to use is called subplots. We call it subplots. When you are going to create subplots, you can divide your interface. Now when you say dividing, let's say our figures are like this. Let's say our figure is like this. Now earlier we have drawn our graph in the same figure, right? We have drawn like this. But what we are going to do is we are going to have subgraphs. Subgraphs means we are going to divide. For example, I can divide the figure into 3 parts and I can draw one graph here, another graph here, another graph here. You can, divide the space for different plots. So this is exactly what we are going to do in subplots. So when you are dividing, you have to define the number of rows and columns. So here we will have one row and then we have 3 columns. So when you are creating a subplot, we will say 1, 3. 1 is row, 3 means you have 3, right, columns. And then each of these we can name. So for example, this is the first one. This is the second one. This is the third one. Likewise, you can rename. Right, let's see how we are going to do this. Right, here is what we are going to do. We will use subplot command, subplot, and we will define how many rows, number of rows, then number of columns and the index. So here we will put 1 to represent that is the first graph. So if you put, let me put pld.show, and if you run it, so now we are getting a figure here, and then I forgot one thing, you have to use plot. x comma y1. Okay, so you divide the plot into 1 into 3 subplots and you select the first one and you are going to plot x and y1, right? So this is x and y1 is sine of x. Similarly, you can have the second one. So when you define the second subplot, we can say how many rows and columns you need. The second one, the second graph that we can put it here. So we can say plt.plot x comma y2. So if you rerun, now we can see there are two graphs in the same figure. So third one, so if I go back to my diagram, you can see we have one row, three columns. Now we have completed 1 and 2. We finish 1 and 2. Let's draw the third one. So to draw the third one, we have to say first subplot, number of rows, number of columns, and we need to select the third one, and then we can plot the third curve x comma y3. So this is called subplotting, which means in the same figure you can have multiple plots. Right. Any questions on this part? Yeah, if you finish up to this point, can you please raise your hands? Naveen, have you finished?
Yes, sir.
Yeah, thanks. I hope everybody is finished. So I think now we have done the basics, and if you need like more, you can visit um, to the Matplotlib website, and you can see how they have actually used to create this. So we have done most of the things. Now, for example, you should be able to understand what this is right now. So I'm not going to go into very detail, but I think this is enough for you to start drawing plotting, right? The next one actually I would like to discuss before machine learning part. I would like to discuss now we have numerical Python or NumPy, and then um, we will also have, we can use these to load data sets, right? Numerical Python, I will first discuss that, right? um, so in this particular case I would like to see how we could use um, some data sets. Let me show you. Okay, I will directly go to the library. So the machine learning library that we are going to use is called scikit-learn, and there you can see most of the data that we could represent using numerical Python. For example, uh, so the data sets we have, so let me use data. We have scikit-learn data sets, and you can use a lot of data, right? For example, we can look at um, already available data. Now, for example, one thing we are going to look at is machine learning. Let me open up that first. This is what we are going to discuss next week, but right. But I think we can discuss the first two parts, especially loading data sets. Now, for example, let me show you the loading data sets, and then what we have is we can use numerical Python to handle this, right? Now, for example, to do this, um, first of all, you need to understand what data sets look like. Now, the problem that we are going to discuss next week, tomorrow, is a classification problem where we have 3 different types of flowers. So machine learning has, can handle different types of problems, but one of the most commonly used problem is classification problem. So in classification, what it does, given a data set of 3 flowers, right? So you collect the data about these 3 flowers, and whenever you give a new flower without a name, the machine learning algorithm can tell us which flower it is, right? Now to do this, we have to collect data. So sometimes we normally use to say, prediction of cats and dogs, which means you have a collection of data on cats and dogs. Whenever you give a cat or a dog, the algorithm can automatically tell us whether it's a cat or a dog. So similarly, so machine learning algorithm can detect which flower it is. Now this is very important. Now usually people do this manually. Early days, there are experts in flowers, they can recognize this. But with the machine learning, now we were able to use computer programs to do this for us. We are not going to, replace any experts here, but as a supporting system, always machine learning can be used, right? Now the data sets look something like this, usually in tabular form. I hope everyone is familiar with this. Usually we will have rows on data points, and the columns indicates any features. So in this data set, basically we are collecting 4 different types of features, right? So the features are, we will get sepal length and width, and then petal length and width, and the class label. So basically you measure all the flowers, these 4 characteristics, and then you collect the label, right? So that's what we will see, right? Today I will start with the data set first, right? So let me start with the data set. So I'll keep aside, right? Let me go back to my numerical Python module. I will take a code window, right? Now, since we want to use data sets anyway, we should know how to use them. So we have not discussed this when we discuss the numerical Python. Now I would like to discuss how to use them. So first of all, you can import numpy as np, and then we have to get the data sets. So we will call dataset from scikit-learn, sklearn. We are going to import datasets. Right. Now you can also load Matplotlib for plotting. So I will explain. Matplotlib.pyplot as plt. We have done up to this point, right? Now to load the datasets, you can look at what datasets are available here. So for example, you can say datasets load iris will load and return iris dataset. So basically we are going to get it as a iris dataset. So we will create a name iris. We are going to get from datasets dot load iris, right? And you can just print iris, which will give you the dataset. So now if you look carefully, this will be a dictionary which contains data as an array, numpy array. Basically it's a numpy array. Then what else? You have target That means we have a label separately, then some target names. So all this information is here. So the full data set is available here. Right. First of all, can you finish and let me know how many of you have finished up to this point? Right. I will, those who, till others finish, those who finish, you can try. I want to get the data set. And can you find the mean values of these columns of data columns? Shall we try that? Right now, iris contain a lot of information. Take out data part, and these are columns, right? The 4 features. I want to find the mean values. We discussed this earlier in NumPy, how to give mean values. So can you try to find mean values for iris data? Right, I think most of you have finished, so I can switch to. Right, so now we have a data set like a dictionary. We call iris. Now we want to access data part of it, right? Now to access the data part of it, the best way to do this is you can get the data. Now, for example, I can get data part of it. Let's say X. I'm going to say iris.data. Now if I say print X, now I will have only the, yes, I will have only the size. If you know the details, we know how to do this. We can say print x.shape should give us the details of this. It says there are 150 records and 4 columns. Right, finished? Right. What is the mean values? Have you found that? Right. For example, we can say print x mean np dot mean x, which will give you mean value for all the values. Right. Then what we need is row wise, isn't it? If you want to get the mean row wise, we discuss x comma. Yes, we have to say axis should be 0. If you say axis is 0, right? Now here are the values for the 4 features. These are the average values. Right. Now that is in numerical Python. But now, for example, if you want to handle Excel files, comma separated versions, then NumPy is if you take NumPy only is not enough, right? So we basically can be use Pandas. It's another library in Python where we can read data from CSV files, text files, Excel files, and so on. So when you want to handle data, right now we look at how we can read existing data in scikit-learn machine learning. But if you want to have more control, because for example, let me put it in this way. Now if you want to restrict, if you want to keep only the first 10 rows, how should you work on this? Can you tell me the code? I want to print the first 10 rows of the dataset. Can anyone tell me how can we do that? First 10 rows. Yes, first 10 rows. Then remember, you can say print what? X. Yes. you can do multiple ways. Now, for example, you can define rows and columns. Right? For example, rows, we can say, okay, I want 0 to 10 and all the columns. We can put it in this form, so which will give us everything. But the shortest form, if you remember, I told you when you have 0, you don't have to specify. So you don't need this 0. Simply you can put it like this. Even if you put like without this one, it will work. Right? But then again, let's say you want to get only the first 2 columns. How can you get only the first 2 columns of data? Yes, first 2 columns. Anyone? So we can have print, let's say X. We need all rows and first 2 columns. So simply we can say 0 to 2, or we can simply say 2. So if you put 2, that actually print first 2 columns. If you want, you can even visualize this. If you have 2 columns, you can visualize this. We have used plot command earlier. Using the plot command, we can visualize this. Right, plotting, let me show you. Now since we have 2 data points, now we can easily do this. For example, we can take first row, first column and second column. Right, we can use a plot command, isn't it? How do you do that? So let me take a code. I think now you need a little bit more practice. Now for example, right, I can say plt.plot first row. How do you get first row? We can say X. Right, we need all the rows, and first column we can put 0. And then next value, we need all the rows but the first column. You can simply say plt.show. That's all. We are getting the first row, first column and the second column. We do it. Okay, why we are getting something like that? This is not what we expect. Because it tries to draw it as a line curve, isn't it? So simply we can have only a color. Let me say in red color with let's say data points in circles. We can say R and O. If you rerun, you see data points like this. So we already know that we have 3 different types of classes. That part I will cover next week, tomorrow. But you can see, we can learn that. Right. Now that we have learned about the numerical Python, we look at how to work with the data as well. But if you need like more control, as I told you, we need to learn Pandas data frame as well. But you know that we cannot do it within couple of hours time. But at least few things I can talk about. Right. Now, for example, if you want to read CSV file or Excel file, right? Pandas are very useful to get the details. You can get it as a data frame, right? So let me give you the basics and finish for today the data frames. Now you can see here the difficulty. Let me show you the difficulty. Now here we have a difficulty. What was the difficulty? We don't know what this column is. We are using these numerical indexes. When you have a very large data set, now here we have only 4 columns, then actually sometimes easy, but if you, let's say you have thousands of columns, if you are trying to access in this way, it's not going to help you, right? So which means you need more control over the data. So when you need more control over the data, then you can go for data frames, or we can use Pandas data frames. Right, now let me discuss how we can create a data frame. Right, now to create a data frame, right, simply we can have, right, 2 functions. Now series for 1D, one dimensional one. Data frame is for 2-dimensional ones, right? So let me finish for today with that one. So the first thing that you need to use is you have to use Pandas library, import Pandas as PD, right? Now PD we have data frames, and in data frames you can use column names. So it is always easier to access column names rather than you use index values. So that is one advantage. There are the advantages as well. Right. So let's look at creating, first of all, a series. Right. Let me look at the series first. Right. Now, for example, when you create a series S1, we will use Pandas method called series method, series, and then you can have a list of numbers like this. So this looks like the same way that we have used for numerical Python as well. So similar output can take, but you see there are more powerful methods as well. I think I didn't run this one. That's the reason why we got the error here. Yes, exactly. Right. Now, here it looks the same. Very similar to a numerical Python array as well. Right. So we can look at the index details as well. So we can say, okay, print s1.shape, that is we have 4 elements, and next print s1.index. Index value is also given. It says it start with 0, ends with 4, step is 1, which means 0, 1, 2, 3. So some information is given. Now beauty right now, there's no change if you use this method to numerical Python. But the beauty starts with you can actually define index with any values. Now instead of numbers, we can have our own set of indexes like this. Right? So we can define S2. We can say pd.series. Same thing here. like in earlier, we will have 1, 2, 4, 5. So this is the default the way. Comma, we can define index now. Early it was a numerical index. Now we can give the values, the label A, yes, B, you can say C, and you can see D. Now, why I am saying this is easy, whenever you want to access it now, you can use these values, right? Now, for example, let me say S2, we will get it as it is, right? But right now you can access element using index. So we can say print S2, we can have A, right? So this is like the naming. We can have our own labels. But if you want to access it in this fashion, you have to use 0, S0. And when you have a large number, it's very difficult for us to access elements. Okay, I think that's enough for today. You can try up to this point. If you finish up to this point, please raise your hands. Right. Anything you want to discuss before we finish for today? We have about 1 more minute to go. Okay, so let me discuss what my plan for tomorrow's session. I will briefly go through the important part of pandas, and then I will discuss exactly the machine learning basics very briefly. So with that, we are going to conclude our series, and then we will have a small assessment, basically mainly on Python, not particularly machine learning. See, because we have not done machine learning, we will actually learn Python for machine learning. So with these, the basic modules, that means numerical Python, Matplotlib, and Pandas, right? You are actually ready to take up your journey to data analytics, right? So this actually session is to cover the basics of Python and also the libraries that you need to cover your data analytics part. So the main thing is a numerical Python. We have completely A to Z covered that part. And then Matplotlib, we also discussed the basic plotting. And tomorrow I will briefly cover the machine learning part. With that one, we will finish covering all the planned topics for this series. Right, so what you need is you need a little bit more practice. As I said, I will upload all the videos so that you can go through and get ready for that. Right, so having said that, let's finish for today. Good night everyone. We'll meet tomorrow for our last session. Thank you.
Thank you.
Thank you.
Thank you, sir.